Hello everybody, welcome. Today we're going to be learning to make a multi-threaded server, and we're going to grab our port number from the command line. So we're just going to do this in pseudocode because I don't really want to write it out. I'm going to flash some things on the screen and you can pause it to get the exact syntax and whatnot. I just think syntax is easy to copy down and the ideas is more important. I will briefly explain what the syntax means, but you should probably be able to get the gist of it by yourself. It's not too difficult. First thing we're going to do is going to make our main. Also, right here at the top left hand corner, I'm going to put that pound includes you need for a little bit, so don't worry about that. So after you get all your pound includes, we're going to want to create a main. And because we're taking things from the command line, we're just going to do real quick. We are going to do int argc and char star argv like that, and this is going to let us take arguments in from the command line and just pass it in. So because this is a multi-threading thing, at the beginning we're going to also want to include this that I'll put right here real quick, basically creating our p thread. So we're going to want to, at the very beginning of our main, just instantiate this mutex lock. So we're going to do pthread underscore mutex init, and then just the name of our lock, which I named mutex, and null. Cool. So the first step in creating a server is to create a socket. So the way we're going to do that is first we're going to really quickly grab a port number from the arguments. So the way we're going to do that is we're going to do unsigned short. Oh, I misspelled that, whatever. Unsigned short equals, I use A to I. You can use anything that does basically like strings in. We're going to do argv of 1, because the first thing we're going to take from the command line is our call to the server, and the second thing is the port number. I don't know, 8000, why not? Cool. So the next thing we're going to want to do is create our socket. So we're just going to do int socket name equals socket and arguments here. And the arguments can be given to you. I'm just going to put it on the screen real quick because they're kind of like default arguments, honestly. And because we're using TCP, it's really simple. So let's just scroll up a bit and look at that. All the way to the top. So right there, in socket. So we're going to want these three. You're just going to want to copy this. AFNet sock stream IP proto TCP. And then we're going to want to make sure there's an error message. So what sock is going to give us, or rather what socket returns, is a file descriptor, which you can just think of the socket number or socket ID. If it fails, it returns -1, which is why we have this error message right here. Really simple. So important thing to note is that, let's just erase this stuff. But the important thing to note is that there are two things that hold information for our sockets. There's this generic sock struct and our IP specific one. The IP specific is what we're going to be putting most of our data into, and then we're going to have to cast it into this normal version to actually use it within our socket programming. So we need to be aware of that. So let's get rid of these real quick. Cool. And go back. So once you create your socket, you're going to want to bind it. Or you're going to actually want to fill out the fields first for just like socket information and whatnot. So we're going to create a struct, and you can just create this. The pound includes make it so this is automatically a struct that's declared. Sudo struct sock adder, which is the type I showed you earlier, the IP specific one. In, we can name this serve address, serve adder. We're gonna fill this out. So we're gonna do serve adder, which make sure you actually use this name. I'm just using shorthand here. Send family equals AF inet serve assign underscore adder dot s underscore adder equals host to network to, there's an O there. Let's just go back actually. Host to network long. We're always going to need to transform integers into network version when we're dealing with them. In adder any. These are all capital letters actually. In adder any. There's an underscore there. And serve adder dot send port. And we're going to do host to network short of our server port number that we got earlier. Go. So that can actually, I'll put that on the screen too, just like the syntax of it right here. Let's just clear everything out. And we can see that right here. So we're going to want to do this stuff. This right here, this unsigned long serve IP is only if you're connecting to some IP address from a client, but because we're using a host, we don't actually need that. We just need this server port number, and we need to set these fields. So you can pause that and look at that in your own time. Okay. So next thing we have to do is bind the socket. So that's the second step. So we're just going to do int status equals bind. Now bind is a pretty simple function also. So let's go down to that. Okay, so let's see what bind does. Let's take a look at it for a second. So bind takes in these parameters, takes in the socket descriptor, the address struct of the socket, and the address length in bytes. Let's see here. That's what that says. Oh, this is a pointer, but it's basically a pointer to the struct. Anyway, so this is the syntax itself. We're going to have a status number. We're going to make sure it's not negative, because if it's negative, then there's an error binding. There may be an error binding sometimes when you create a server and use a port number, and then you try to immediately reuse the port number after the server closes. But just be aware of that, and you just have to give it a couple of minutes, and you can retry it. So right here we have our socket number that we got from creating a socket earlier. And when I was speaking about the generic versus the non-generic, the generic versus the IP version of that struct, we can demonstrate it right here. So sock adder is the generic version. So we're casting this struct, which is initially, I believe, sock adder in. We're casting it to a pointer of type sock adder just so we can pass it in, because that's what we need in order to pass it into these socket, this POSIX socket programming. Right here we can just get the size of server adder, because that's what we need. And that's good to go. Don't forget to also put this ampersand here. That's important. Don't forget that. So after we bind, we're going to listen, which is the next step. Listen. So we're going to clear this out. Listen is also pretty simple and straightforward. So what listen does basically, it's a socket that looks for incoming connections. It doesn't actually connect. This isn't really the connecting part of the socket, like that connecting action. It's just seeing is anything coming in, right? And once it sees something coming in, then it's going to call accept. Accept, okay. So it takes in only two arguments, the socket and queue limit. And so we're just going to take status again, right? So the way we're going to use this is we are going to take status. We can clear all this out. It's just an integer we declared earlier, set it equal to listen. Listen. And then our socket number, which is the socket identifier we got earlier at the very beginning. So we could just go say socket. And then the backlog number, which is basically the amount of connections we're going to let just like chill out, basically, while we're accepting connections. And we're just going to set that to 50. That's a pretty good number. Cool. And that's all you actually need. Of course, you also want to do an if statement for status. And if it's less than 0, an error. Cool. This doesn't look like a C. That's definitely a C. Anyway, so let's listen. So next, because we're multi-threading, this is where things get a little different. Okay, so the next step is accept, but here's where things get a little tricky because we're doing multi-threading. So let's go all the way back to the beginning of our file. So right here, I'm gonna put another pound includes you need. All these are just for p threading, because we're gonna need to use multi-threading to let our server host multiple clients at one time. So you know how I said listen? What listen is just a port that says, hey, someone's at the door. Someone's at the door, right? They're like knocking. They want to get let in. This isn't really the function that lets people in. The function that lets people in is accept. So that's what we want. Next up, we're just going to do accept. But before we do that, because every new connection needs its own thread, we need one accept per connection, or per client, basically. So the way we're going to accomplish that is that we're going to set up some multi-threading. Now the first thing we need for multi-threading is we need to actually set up a struct just so we can pass the client socket into each thread. So what we're going to do here is we're going to create a struct of whatever name. Thread args is pretty good. It's a pretty generic name for multi-threading. Thread args, and we're going to put int client sock. Now this is, it's going to hold our new socket identifier or descriptor, a socket descriptor, for the client that we are accepting. So we're just going to put that at the top of our function. So the next thing we're going to do is we're going to go back into main. So let's just clear this off. Within main, at the bottom, so let's say this is listen. And there's a bunch of code up here, just up here. So after listen, we're going to need a while loop. Right? So say while true. See, we don't want our server to actually ever shut down unless it's due to an error. We definitely don't want it to shut down after accepting so many clients, because the server needs to always be on. And that is what a server is. It's just an always on thing, like machine access point. Anyway, so we're going to say while true. And this is where we're going to actually create our threads and accept our connections. So we're going to create a new socket address structure for each client. So we're going to say while true, struct sock adder in, which is, remember, is our IP specific version. Goes client adder. We're going to say, we're actually going to take sock length t, sock length. It's actually all lowercase, so sock len underscore t, address length, equals size of client header. We're going to create an int client sock, and now we're going to do that client sock equals to accept, which is going to accept the connection and actually make the connection. So we're going to have the server that's listening, which is, we're just going to name that server sock. We're going to want to pass in the address of our client, right, that we just made in this client address struct. So we're going to cast it real quick. So struct, we're going to cast it to the generic type. So sock adder star ampersand client adder and then we are going to have the length, which we declared right here. We could just do a length. So that's our accept function. That's our accept right there. And we're just going to put in some error handling. So we're just going to say if client sock is less than 0, then error, whatever. Cool. So this is basically what our accept is. I will put a screenshot of this neater down here in this box, and you can check that out. So the next part we're going to do, we're actually going to make our new thread, or we're going to create the p threads now, basically. But before we do that, we actually have to fill out that struct we made earlier, so that each new client basically can access its port. Well, so the client will create a new port with the server. Say this is the listening port, and then once it gets its alert that it's a listen, if the client's here, the client will connect to here. And this ID, we need the server to know it when it's sending shit, so that it knows which socket it should send to. And each thread's going to have its own one if there are multiple clients. Like that. Cool. So we're going to fill out that struct we made at the beginning, just so we can pass it in, because the way you pass things into threads is through structs. That way you can pass in multiple data. Even though we're only passing in one thing, it's better to do it this way so we can always add later. So let's create a struct. So struct thread args star thread args, because this is our thread arguments. We're going to do thread args equals new struct thread args, and then we're just going to say thread args arrow client sock, which is the one inside the structure, sock equals client sock, which is the one that we just got from our accept function. Once we do that, we can now create the p thread. So let's do that real quick. And we're just to do p thread underscore t thread ID and we're just creating a new thread ID for this thread. Let's say status, because we already declared this a long time ago. We can just keep using status over and over. Equals p thread create. And let's pass in the thread ID, the address to thread ID at least. Thread ID null. This is just the default argument for the second thing. Thread main. Let's go back. Thread main, which is what we're gonna, this is what we're gonna name our thread. We're gonna have a function called thread main, which we will make after this. Okay, thread main. Let's just undo that. And then we're gonna cast the struct to void pointer, because that's what we need to do for when we work with pthreads. We need to cast things to void pointers. So void star thread args. Thread args. And then we're just gonna make a little error message or error checking for status. So if status is less than 0, error. Cool. And the very bottom, outside the for loop. This is all still within that while loop equals true, by the way. So outside the while loop, we can just do return 0 if you feel like it for the main. It doesn't really matter in my opinion. Okay, so let's just go to the very top again, and because now we've created our multi-threads, we actually have to create the thread function that works with this. So we'll just clear this out. So the top, kind of like any other function, we're going to make the thread. And how we're going to do that is we're going to say void pointer, type void pointer, thread main. Same thing that we passed into our pthread create. It takes in the parameter void pointer, star, and just name that args. So if you notice, we casted our struct earlier into void pointer, and our thread main function, which is our one of our multi-threading functions, or like the multi-threading function. This is what spawns off of the main process. Is also type void pointer. This way we can pass structs straight into main, because this only takes one argument right here. Anyway, we're gonna say struct inside of it. Struct thread args. We're gonna make a new struct thread args pointer. Thread args equals, we're going to cast it back into a thread argument, or thread args pointer type, struct thread args star args. So basically we're going to say, we're saying right here, create this new pointer and point it at the argument that got passed in, that we're casting this void pointer now back into a struct thread args pointer. So that's what that is. So now this thread args is holding the information that we passed in. So we can do things like this. Oh, that's not an eraser. So we can do things like get the information, like the client socket that we want. And this way, because we accept a new connection in this while loop with every iteration, we can go through the queue of pending, I guess if you want to call it, connections still, people at the door, and be like, accept them, right? Let them through the door, pretend they're walking this way. We can ID them, and now we can keep track of their own each ID because each person is linked to a thread. So that's pretty cool. And each one has their own ID, and because we pass it in pass it into each thread will have a separate ID, and each thread will be one-to-one with every connection and everything we accept. I don't want to delete all of that actually. I'm still using that, so let's just erase the rest. So what we're going to want to do here, we're just going to want to store the information we got passed in. So in client sock, this is technically still the server, right? We're just creating like new parts, in quotes, parts of the server to do with each client. Kind of, not really. Anyway, it's a way you could think about it. It kind of, the logic works the same if you think about it that way, honestly. Anyway, thread args. There's an E there. Thread args. Arrow client sock. Client sock. Cool. Then once we get that information, we can just delete it. Delete. Make sure you always clean up your stuff. So delete thread args, because we don't need that information anymore. We already got all the info we need. If you pass in any more information, you can just grab them here. You still want to delete this as soon as possible, so you don't forget. Delete thread args, and then you can process whatever processing you have to do here. And then at the end, basically want to close your connection. Client. Or I think it should actually just close. Close client sock. pthread. Detach. So we don't want join, right? We don't want the main thing waiting for everything to finish. Pthread detach. And then pretty sure we can just pthread exit. Well, let me double check that real quick. Okay, actually, you want to do pthread detach before client sock apparently. So pthread detach, pthread self, and then you can return null. Return null. And that's how you close it out. Now, you also want to kind of implement mutex locks, just if case you're like doing anything that needs to be mutually exclusive, like altering shared data, anything like that. You're going to want to put those at the beginning and the end of whatever process you want to have mutual exclusion with. But that's up to you. You can definitely look up mutex locks on your own. There's documentation. That's pretty good. Okay, everyone, that's it for the video for today. I helped you understand how to implement a server that can handle multiple clients using multi-threading. Leave a like if you liked it. Leave me any feedback down below. And I'll see you in the next one. Peace.